Okay, so we're gonna start with some weather variables, the things that make weather what it is. And the first that you read about last night in that reading is temperature. So again, we've talked about temperature, shouldn't be new to you. It's a measure of average kinetic energy. So how fast those molecules are moving. So the more energy they have, the faster they move, the higher the temperature. And this we talked about with the conduction, convection, radiation, so it should be pretty straightforward. I'm not going to belabor the point, but I will talk about how it relates to the unit that we're talking about with weather. So we use a thermometer. You know what they look like. They're those little glass things with the red in them. The red is not mercury. Mercury is banned from schools, and so we use alcohol in the thermometer. So that's what that red stuff is. It's not alcohol you can drink. It's alcohol that is, it's like ethanol or methanol actually, that is used just for the thermometer. When you heat it up, what happens when something heats up? It expands. The molecules move further apart, right? And when that happens, there's only one place for it to go. When it expands, it goes up, 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 up. All right. When it cools, the molecules get closer together, and this level sinks. All right. We measure. We have those three different scales we talked about before: Fahrenheit, Kelvin, and Celsius. So we have those three different scales, and we use on a weather map, we use these things called isotherms. You may remember this from 8th grade. We talked a little bit about that in 8th grade, I know because I taught it. Lines that connect places of equal temperature. And if we look at a map, and I'll pull up a map here in a second. Oh, something I had to show you. This is unbelievable. I was reading something in the news the other day, and those of you that are in track might appreciate this. Those of you that aren't in track should appreciate this anyway, because I'll tell you what, if this guy right here can run 7 marathons, which is 26 miles in 7 days on 7 different continents in a row, I'm sorry, you can do a little bit of earth science. It's not that hard. It's not like you're running 26 miles 7 times in a row, one every day. Um, so, very inspiring story. This guy is unbelievable, and I just thought that it would be really kind of interesting. If you get a second, you can always go to search for this guy's name and do a little research on him. But back to weather. He must have had good weather when he was running. But if we look here, we have these different temperatures. You've seen these maps before on the Weather Channel, on local news, and it gives you all the temperatures. And basically, you have all these cities around the country that have weather stations, and they read the temperature. They report it to the National Weather Service, and they create these maps. Now, this map is kind of colorful, and that's fine. It helps you to see what's going on. But the way that real meteorologists look at weather maps is here's your isotherms and temperature. So it shows you the temperatures, and these lines you can see right here says 30 degrees. Anything that's on this line is at 30 degrees. Anything that's on this line is at 40 degrees. Anything that's on this line is at 50 degrees. And now I know you're going to say, well, that says 41, but it's on the 40-degree line. Part of it is that we're looking at something so big, we're looking at the whole United States, and this point for 41 might be just on this side of the line, just next to the line. And when they draw the line, that's just where it ends up. So as you see, this connects places that are all at 40 degrees, and this connects places that are all at 50 degrees. And you can see that there's a central part where the coldest weather is right in here. And actually, sorry, the coldest part is here, and it's moving down into the eastern part of the United States, pushing down south here, and you get this warm air down here is sort of moving its way up. And what the weather stations do, what the Weather Channel does, when they get that information, they color code it. So it's basically the same information. You can see it's colder up here. You have this warm air moving up. This is a little bit more current. The time is a little bit more current than this map. The times are a little bit different. So that's why there may be a slight difference there. So that's what we use those for. We use isotherms to connect these points to show us not just what the temperature is going to be, but Temperature is also very important when we start looking at other factors in the weather. What I'd like you to do is, if you look at the reference table, and I'd like you to take out your reference table, turn to page 13, and you'll see this page. And you'll see on this chart right here, here's temperature, and here's air pressure, which we'll get to in a minute. But on that scale, you'll see that water is boiling up here at 100 degrees Celsius, 212 degrees Fahrenheit. The room temperature down here, freezing point down here at 0, room temperature is at about 20 degrees Celsius. You can convert these. This diagram is not the best. It doesn't show it like it does on your reference table, so I'd like you to use that to try and answer these questions. And I'd like you to also answer these. So room temperature, I gave you the Fahrenheit there. Body temperature is 98.6 and 37 degrees, 310 degrees Kelvin. So that's temperature. Pause the video, answer those questions. The next one is air pressure. So another variable that we look at is the pressure, the weight of the atmosphere pushing down on us, and it changes depending on the temperature, because as air expands, as temperature goes up, as we talked about before, the air expands and rises, and so the pressure will get lower if you get warmer air. So we have those two things happening there. The weight of the earth, if you can think of a column of gas sitting on top of the earth, and you can see right here a diagram of this as the air, if you imagine the molecules of air, they actually get more concentrated as you get down to the bottom. So if you're underneath this column here, all this weight of this air is pushing down on top of you. It's sitting on top of us, and we'll do a couple demonstrations with that, and I'll let you play with crushing a can and those sorts of things. But as you get higher and higher, there's fewer molecules, less pressure pushing down on you, and so the air pressure goes down as you go up in the atmosphere. And that was one of the things that we saw in the reference table. If we go back one page here, or 2 pages, or go forward a page, sorry, right here, air pressure goes down as you go up. So as you go up in the atmosphere, the air pressure goes down because there's fewer molecules pushing down on you, sitting on top of you. We use something called a barometer to measure air pressure. Air pressure is a crude barometer, or a simple, very simple barometer is a tub of water, or a beaker or a tub of mercury with a column of glass that is evacuated. There's no air in it, and the air is pushing down on that. It's pushing down on this mercury and forces it up in this column. When there's less air pressure, less air pushing down on this, then this will go down. As you get more pressure pushing down on it, it forces the volume to go up in this. We use something called inches and millibars to measure air pressure. And in terms of inches, it's inches of mercury, and it really is how high this column of mercury would be pushed up if you have a mercury barometer. That's where the inches of mercury comes from. On a weather map, if we're using a barometer, what do you think we would show? Like we showed isotherms, we might show on a regular weather map yes, you got it, isobars, lines that connect equal places of equal pressure. And those places of equal pressure, if we look at this, here we go. Here are our isobars. We measure, these are in millibars. It's another unit of measurement for air pressure. And here we have 1024. All the places that are along this line are the exact same pressure, 1024. They go up by 4 millibar increments. Here's 1016, 1020, 1024. And the highs and lows that you see on a weather map are from those. So highs, lows based on the millibars from that. And so we use that as our way to talk about what's happening with pressure, because winds are all about pressure differences, and we'll get into how that pressure differences affect winds. So again, here's that notes on this mercury barometer. As air pressure is pushing down here, as this is pushing down more and more, if we get more air, higher pressure, it causes the mercury to push down and up in this tube. And the higher the pressure, the more weight is pushing down on us, the higher the pressure. And then vice versa. If you have the pressure drop, this is going to go up. The air is rising. There's less pressure pushing down on this. There's air is rising above this basically, and that forces this column to drop and fill up this tub. And that's pressure and temperature. Um, Answer the questions on, oh, one last thing. There are some questions on air pressure, and if you look at the reference table on right next to the temperature is air pressure, and you can convert back and forth. The thing that you want to be careful of is the scales are different. Here's 1024.0, here's 1028. So if I zoom in a little bit, you'll see that each of these are worth 1 millibar. So 1024, 1025, 26, 27, I'm sorry, 24, 25, 26, 27, 28. And these go up at a different scale. Here's 30.20, 30.30. So each of these lines is worth 0.01 inches of mercury. So these go up by 0.01, these go up by 1 millibar. So just be careful of that. Do the conversions on this page here. Oops, sorry, there's somebody's ear. Let's talk about that. Here, do these conversions here. Normal sea level is on there in millibars and inches. And we'll leave it at that because this video has gotten long. So if you have any questions, ask me. When you get the notes done, you can do the demos that are in the lab, and if you have all your other work done. So get this done, have me check to see how you did, and we'll go from there. Hope you enjoyed it. Hope